I do want to make a point with the Dana Lewis and the stage, the quantified self meeting. One of those people that was on that stage is now employed by Dexcom here locally in town. So let's talk about a private sector company taking advantage of some of this very cutting edge kind of work. So Ben West is over there now, and someone else from that group. So, Rick.
Rick Triano again. Just more of a common announcement. I agree and wholeheartedly agree that the taxonomy and the terminology is critical. My colleague James McLean, and I think Donna's going to talk about the radar project a little bit. We talked about how we're going to do this with sensors and basically labeling physical activity behavior. Because we're a little slow and unmotivated. Sebastian Chaston and Joran Halbestad have initiated an effort that they're calling Alphabet, which is to develop a behavioral taxonomy related to physical activity in particular. And we're talking with them about expanding that to capture sedentary behavior and those kinds of things. So that's just kind of some background information there. You don't know this yet, some of you do. The NIH is hosting the ICAM-PAM meeting next June, the International Conference on Ambulatory Measurement of Physical Activity and Movement. And we're planning to have a session, maybe a pre-conference about Alphabet, but certainly if you're interested in, they're trying to do this kind of a Delphi method, get a broad consensus. So chat with me more if you want to know more about that, because I think, this is one of those things that's critical, but it's also something that we don't want 5 different people doing 5 different taxonomies, because then we don't get to where we want to be. Thanks.
Thank you for sharing that.
Other questions? So again, terrific presentation, Eric. Can you just comment just a little bit more? I know you and Eric, and Daniel Rivera have been borrowing some of these methods from the engineering world. What have you, as you poked around in that, in engineering, the engineering sciences, how do you, can you unpack that a little bit more for us about the implications of the engineering sciences for what we're doing, especially in control and systems theory and whatnot?
Sure, yeah. So, Kevin mentioned my colleague Daniel Rivera, who's a control systems engineer at ASU. He's been my close colleague on all of this work and building those dynamical models. I think the important implication that it's really struck me is just the flip in logic, and this idea of really putting the decision first. So, control systems engineering is about trying to support complex decision-making or decision-making in complex dynamic environments. So like as an example for this, one of the early controllers that was developed was about the autopilot for a boat, and so if you think about this as a decision-making problem, it's like the boat wants to go that way, right? But from the controller's standpoint, well, then what you need to think about is, well, like, okay, so we've got error in terms of where the boat's pointing versus where it wants to go. We have error in terms of where it moved in the past and how it was kind of oscillating. And then we even have a rate of change on like how that changes in the future, right? And so you basically have this representation in this one variable of like how the boat's moving relative to its point. You have actually a whole lot of information actually to help you make a decision. That's a simplified starting point for it, but the thing that really struck me, I bring that up as an example for this in thinking about control systems engineering, because it flips this, it very much focuses more on these causal explanatory models as the target. It's not necessarily asking the question of just if there is a relationship, but it's actually asking how is this mechanistically functioning, and it's doing it always in the service of a decision. And so I think this is back to your point about this, that I think you mentioned this, measurements and interventions are hard to separate. In my opinion, this is one of my mentor, my PhD mentor, Rich Contrada, he always emphasizes, he's like, anytime you do an intervention, it's an experimental test of a theory. And so just think of it as that. You can also think about this as a way to build science, right? So I think about it the same way. With control systems engineering, there's this very concrete decision that's going to be made on intervention options that are going to happen. And when you put that first, it actually simplifies a lot of the domain, because it's like, well, what could feasibly influence the goals in this given moment? Oh, well, now I know it's not everything. It's just, maybe their stress, their calendar, their weather patterns, it's complex, but at least I have a sense of it, right? And every time you keep looking at these decisions, you start building these models of understanding how behavior actually works. And then by extension, hopefully you actually then start getting to this generalized truths that science is striving for, but it's taking a much more pragmatic focus and moving forward the science.
Yeah, I love that, the experimental test of a theory. Every time you do something, it is, and we now have the capability of actually measuring just in time, right away, quickly, via the technologies that you've talked about, exactly what happened, and then course correcting based upon that over time. So it's great. So other questions? We're going to be inviting David and Eric up on the stage to ask each other questions potentially, and then also dig a little deeper. And I'm hoping that this will help us set the stage for again what you might consider in the breakout sessions after the three life cycle sessions that we will have. So any additional questions for Eric right now? He covered a lot. Some interesting stuff. So, okay, so let's move. David, can you come on? And can we, actually, I'm going to moderate this from up here. So we have a few minutes again to sort of do some overlapping discussion, and what I heard a lot here was this need for theory. They both really settled on this concept of theory, and so again, what might you ask each other about the theory, about the experience that you've had, David, in this area, and now seeing what, I don't know if you've ever seen Eric talk about these kinds of things, but those of us that know him have seen him excited in talking about this previously, but any things that you would ask each other related to this discussion?
Well, I think one thing that's fascinating about Eric's work is the extent to which it lends itself to, you might say, general statements one level back of abstraction, such as do this kind of work with an individual and you'll help that individual to achieve some success, versus on the specific things you do, them being still not really generalizable. So say, well, for this individual, it seems that this kind of event or stimulus seems to lead to this kind of effect. And that may be fine, but it means that, in fact, it's difficult to then make blanket recommendations, which may be perhaps where we're going. Maybe we're not going to make blanket recommendations to say, eat a low-carb diet, eat a low-fat diet, eat more of your calories in the morning, eat more of your calories in the evening. Yeah. But in fact, we'll be going to the point of saying, engage in this sort of process by which somebody like Eric helps you through a series of pathfinding activities, find what works for you. And so it may lend itself clinically to good outcomes, but may not lend itself to easy statements about how things work in general.
I think that's a totally fair statement. And I think this is actually why I brought up those different sources of variance, right? Because each, I don't know those. I mean, those were completely made up. It was just more of just recognizing that there are these different sources of variance, and we need to be more mindful of how our evidence base is building them out, right? So if I had to, this is just a complete, hunch wager, right? I feel like we've been increasingly using methods that have been trying to get us towards those general recommendations, right? Like 10,000 steps a day, or 150 minutes, or the dietary guidelines, right? We've been striving for those for so long that we're kind of like, we've probably parsed out, except the measurement actually. So I could focus more on the physical activity for now. On the physical activity side, I feel like we're getting to a place where we're probably going to be able to get more benefit in terms of our health outcome by actually having more personalized recommendations, right? Like, what is the right target for you for today, for a given moment, based on everything else going on in your life? Particularly, for me, I think about this more so from the broader perspective of this multi-level aspect of health, right? It's not just about the physical health that you might be optimizing, but what else about the social health? Like, let's go back to that diet example for a moment, right? And you might eat some really crappy food on one meal, But if you compensate that, but part of that is you're bonding with friends and family, right? And so there's this strong social benefit that could feasibly have a good positive impact on your overall health. That as long as it's compensated for with some physical benefit in the future becomes really important. So for me, it sets up this temporal dynamic of it's not just the outcome measure, it's the temporal dynamic, it's the relation, and therefore, and the more we get more into that, the more, as you said, idiosyncratic it likely would get. But that to me is, it's interesting you said it would be a person like me. I would say, no, it's not a person like me. It's the computational model coach that's helping me along to help me understand myself. I think actually if Larry, I wish Larry were here, because I think Larry is kind of an example of that type of person who's really using data to, constantly interact on themselves. I wonder if I can flip it to you and ask you a question then. So building on that point, what is your, so I'm with you on that, on your measurement claims. As I said, I don't do interventions on diet largely because I don't feel like comfortable enough knowing what I'm measuring, and therefore I don't know how I'm optimizing. I don't know how to impact on health. Where do you see the opportunities? And in particular, what are the meaningful signals in your mind that when it comes to diet? Obviously, energy intake and calories is part of that, and I know that was the core focus you were thinking about, right? But you brought up those questions that you were getting into, right? What are the other types of constructs that we want to be thinking about when it comes to diet? And as another example, it's like kind of the social benefit or the cultural aspects to it or something. And how might we be thinking about that as more of a broader, how might we be able to use that better measurement to be able to better understand this concept of eating overall?
Yeah, I think in the long run, what we'd ideally like to be able to know in principle for people who want to allow us to know that, that's an issue as well, but is we'd like to know, I think, every molecule that goes in. We'd like to know when it went in. We'd like to know sort of, did it go in as a piece of broccoli, as a string bean? Did it go in hot, cold, et cetera, et cetera? I think that's all we'd like to know. And of course, then we'd like to know every molecule that goes out. And I think, your mention of the toilet idea is not at all fanciful or unreasonable. So I think that's a great way to go potentially. And what you just need is something that does it on this end. And right now we're at very primitive levels. So we're going to hear from, I think, Edward Sazanoff or his students and postdocs during this meeting. And he'll talk about things like things that count the chews, and then from the chews try to say both how much went in and maybe some sense of, correct me if I'm wrong, Edward, but some sense of what went in. But obviously that's the most early stage. What I'd really love to do is have something where there was a little something the equivalent of an MRI in your mouth, and as everything went through, it told you the complete chemical composition, the complete atomic composition of it, and the temperature of it, as well as thermometer and so on. Do I think that that's plausible? Yes. Do I think it's plausible this year? No. But I think that's where we want to be moving toward, and I think we just need to sort of create that impetus to keep moving us in that direction.
So I'm just going to throw a random idea just because something I've always wanted someone to create this, and I don't know if it's possible, but couldn't we put like a tooth cap or something that has a sensor array to pick up on at least amount of saliva in your mouth or other things of that sort, have a small Bluetooth signal to be able to transfer that information and then charge it through its own energy capacity, because you're chewing. By definition, you could actually create a small amount of energy. I'm wondering if there's, I'm just throwing that out as a weird random idea, but I think to try to extend your point, if we let go of self-report, we could start thinking more creatively, and maybe we just need to talk to our orthodontics friends to kind of think through some, to me, it's where is the source of variance, right? Based on Edward's work, right, you're going to get better signal for a lot of activities based on the sole of a shoe than from your wrist. Why? Just because there's more signal there, versus this is pretty messy. Right?
Well, there actually are advances being made in this oral sensing. There's a group here at UCSD, Joe Wang's lab, that's doing work on oral sensor of chemicals and other kinds of things, and that mechanical aspect would not be a difficult thing to think about putting in. And in fact, I think they're going for there's an NIH RFA out there. So this is what hopefully you'll be thinking about. Again, thinking about this, what if we had this? What if we could this? Is it possible too? So please, I want to bookmark those, and we want to have a few of those. What if we had this? What if we had this? What if we had this? Because one of my favorite books a long time ago was a book it was What's Not Possible, in so many words. They sort of ask scientists in leading areas, what can't be done in your field? which really created a boundary in their field. It sort of said, well, in our field, we don't think we can do this. And knowing that, it's a little bit like that benchmark. It's sort of like, well, then we can do everything up to that, potentially. So exciting way to think about this. I've got a question that I want to put to both of you. You both talked about theory. But again, there are many fields. There's psychology, there's engineering, there's systems theory, there's all the stuff that the atmospheric scientists and whatnot are using. How is there a grand unifying theory? As somebody trained in mathematics, is it math? I mean, is there, or do we let 1,000 theories bloom and test and retest and retest, as Eric sort of inferred? And I really don't know. I mean, what do you folks think?
That's a big science question, isn't it? So I think that there is sort of, at some level, I don't want to say necessarily one grand theory, but there's one grand thing, right? So, you know, we have this universe and it's made of atoms and subatomic particles and so on and so on. And there are people in the room and at universities who know much more about that than I. And I think everything else is sort of built of that stuff and has to obey the same laws. However, what we get is that at a certain point, things become complicated enough that it may be too difficult to theorize about the system, these complex systems, working solely from the level of these subatomic particles and very basic ideas, and that we may need a sort of second layer or multiple other layers of ideas that allow us to start to theorize it at that point. And that's a little bit tougher. But I think that may be where we need to go at some point, and we get into these challenges of chaos and emergent properties, right? Engineers often do very well with certain kinds of things in making things work, often because they're dealing with that sort of more first layer system where we do understand things and there aren't emergent properties, right? We love to talk about complexity and we're going to figure it out if we're complex. But actually the way we've had a lot of progress in things where we really have made stuff work, like airplanes, is because we understand the systems and it's, relatively speaking, not so complex and there aren't emergent properties, right? You don't want emergent properties in your airplane. You don't want to get up in that airplane and say, you know, I know all the individual parts should have moved in this way, but suddenly when we put it together, it was hard to understand how it worked. That does sometimes happen, which is why there's field testing. But in general, we want to be able to understand that. We need to get to that point a little bit more, and I don't think we do have that unified theory. And I do wonder, it may not be completely possible. It may be that when we get to behavior, it may not yield itself to that. It hasn't to date, right? To date, we do not have a broad general theory that allows us to easily predict in any one situation how someone will behave with any great degree of fidelity.
But as Eric has pointed out, we certainly have now an increasing observatory with all of these microdata and other things to begin to at least gather some data to which questions could be asked that could test and prove theories. Eric?
Well, so I mean, you picked up on part of my take on this. That I mean, the way I think about it a few different ways. One is first thinking about it in terms of, you know, E.O. Wilson has his book Consilience, which is basically arguing for what you were just saying, that there's this emergence, particularly building on the logic of evolution, as it seems like there's interesting parallels across a variety of domains that build on evolution, right? So you could make an argument that there might be some general principle that is useful across that, that can cut across those, as per like the level 1 point. And it ultimately, getting back to the engineering phenomenon, you know, to me it's what decisions, what is the use, what's the benchmark that you're going to be using this information for. You can have a very general theory that's describing a phenomenon, but it's not going to actually give you any information to help you make a decision, you know. And so my fear is if we were going for that true unifying theory, it wouldn't have the details to actually help us in health. That's the third. But then there's a third part to this as well, which is this is a computer science concept, but you know, there are many, many layers of programming that allow you to use your iPhone or your Android or your computer, right? There are so many sub-layers of programming that are going on within this thing, and most of us don't see that, right? This is an example of emergent properties, you know, whereby you have the basic binary code at the bottom of, actually you have the hardware, right? And then you have binary code telling the hardware what to do, and then many layers up, operating system, and so forth and so on, right? Conceptually, this is a bit of an analogy on kind of theory, right? Each one of these is describing some basic phenomenon. How is the physical world functioning? How is the digitized medium between physical and otherwise working? And then working our way up so that then the emergent properties of you being able to open up the phone and get your weather again or whatever thing you have where you don't actually have to think about how that happens, it's pretty incredible. And so to me, that's probably a closer analogy. It's even a more broader version of it, but that's the kind of the way I would think about it, that there are these foundational theories that are building up on each other. The key problem that I think we're running into a lot right now is, going back to that analogy, is there's this idea called leaky abstractions in computer science. And so if you don't know what a leaky abstraction is, basically this idea of like when you're living in this high abstract world and you're doing everything according to the rules of that world, and something should work and it doesn't. And the reason why is because the level down, it doesn't work, and ultimately it's because you had to do some small translation from the more binary code into your operating system and so forth and so on that allowed you to simplify it so someone else could use it, right? And so that conceptually is a core part of our theoretical problem. We basically need to be better understanding how leaky abstractions are influencing us. To me, that's actually the more interesting spots for actually better understanding theory and being able to build on what Peter was getting.
So this comes from the technology world. Eric has spent a lot of time with folks in technology, and I wanted to, my next question, not seeing others, so again, I'm going to jump in here. My next question relates to how can the technology world, we have representatives of the food industry here, the nutrition, how do you see that kind of partnering moving us forward in some way? What new kinds of relationships could occur in this way to sort of drive forward, and what's the big thing in the room that we're missing? What obvious thing? You mentioned swipe cards, for example. I mean, we did research almost a decade ago using swipe card data and population level, looking at trans fats, I think, and we actually involved computer scientists in this and whatnot. So we've been there a little bit with the Safeway, or Safeway was the company that we work with. But what other things? Because again, what should we be thinking about as a group? Combined group now of folks across these domains of technology, science, food industry, and whatnot. And jump in if you have an answer out here, if you have a suggestion. And again, it doesn't have to be an answer. It can just be a thought.
Sure. So, I think there's endless possibilities, and they range from very simple things like continuing to fund research. And one of the things I think that's interesting is when you look at the pharmaceutical industry versus certain other industries versus the food industry versus the restaurant industry, you see very different understandings about, or cultures about, funding of research, both for external organizations or even just doing the research. Pharmaceutical companies for a long time have realized they have to have data. And they have to have data about the safety and efficacy of their products. If you were to say to Barnes and Nobles, you sell this book here that says, teach yourself algebra. Do you have any randomized controlled trials showing that the book actually teaches people algebra, that people who buy it are better at algebra at the end? Probably not. It's like, what? Randomized controlled. It's a book about algebra. It says it's about algebra. Why do I have to say more than that? We're sort of getting to the point now where with things like food and restaurants, we're kind of in this middle space where we sort of feel like people ought to have some data. And I think there ought to perhaps be a culture of, if you sell 1 billion of something, you ought to perhaps know what people do with that stuff and what happens when they take it. And I've sort of been struck at times when I talk to colleagues in academia who aren't very involved with the food industry. They have lots of paranoid fantasies, and they talk about how the food industry has all this exquisite knowledge, and they know how to get us addicted, and they know exactly what the food does and what people do with it and so on. And then when I go and consult with food industry and I say, well, can you tell me about this? What do people do with your macaroni and cheese? And they say, the 12 moms in the focus group said this. You're kidding, right? That's it? You got 12 moms in a focus group? And I say, they liked it a lot, and the taste profile changed when we changed the salt. And I said, well, what happens if people eat it for 30 days? We don't know. Do people eat it for 30 days? We don't know. And so I think there actually isn't a lot of knowledge, and I think it'd be nice to move toward that. I think almost a model where you said, you know what, Goodyear needs to test their tires, Pfizer needs to test their drugs. If you sell 1 billion servings of something, maybe you need to figure out who eats it, when they eat it, what happens when they eat it, what happens when they eat it for day after day after day, not just when they taste it in your taste test, and so on. So I think creating a model for funding that, for funding in a way that the public finds acceptable, they obviously have concerns about food industry funding, I think is important. And then I think there are, getting back to the technology, things that can be done, again, if people are willing to do it, which sensors in food, taggants in food, so you can start to tag food and follow it up. You can put sensors in it. When that bag is opened, it sends a radio signal, and somebody knows a bag was opened at 11 p.m.
This is great. It stimulated somebody to come down to the microphone, so I want you to get a chance.
Robin Shook, Children's Mercy. On the point that was brought up at the end of David's talk about doubly labeled water, an alternative is using activity monitors. So shameless plug for my poster today, I use the physical activity monitor to measure energy expenditure and use that to calculate energy intake and compare that to doubly labeled water. And there was no difference between the two. And obviously, the activity monitor is much, much cheaper than doubly labeled water. But then linking that to this question in terms of industry and academic partnerships and technology, Jawbone bought the SenseWare armband and promptly killed it. And so that's an example of they didn't see the utility of that, the information that the SenseWare was really good at measuring, which is primarily energy expenditure. And so I don't know what the question is, but there is a disconnect, I think, at some point between what industry needs and what academics need.
I think that was actually in line with where I was going to go with this comment. Yeah, to me, the important part of this, I agree with everything David said. There's a lot of great opportunities if we could figure out how to make it work. The problem is we don't know how to make it work. We don't know how to set up those relationships. And, it's like, I guess I'm putting on more of an economics hat, but we don't know the incentives. We don't have an understanding of why would industry do this, but with that said, that was the depressing start of this. I think there are actually examples, there are some emergent examples of this where companies are doing better because they are taking advantage of data. And I think Silicon Valley is particularly a good example of this, right? We brought up all the data scraping that's going on so they can sell you better ads, right? But there's also this concept called lean startup and lean methods, if you have heard of that. But it's basically it's sort of a simplified version of how you do science. I wouldn't call it science, but they're trying, and I appreciate that. They ask a question, they try to gather some data, and they see how it works out, right? It's like just like you were telling about the animal models, right? So I think so to me, I think the challenge we need to be thinking through is how do we actually help them to see that if you know how they're using their mac and cheese 30 days out, that will help them to be able to do better at selling products and improving their bottom line. If we can create a more robust scientific framework that helps them make that type of decision making, I think that we might have something, I think we might have